I am Anil Kumar. Welcome to my series on trigonometry. In this video, we'll discuss trigonometric equations. Treat this as examination practice 1. Most of the equations taken here are simple. We'll understand all the concepts to solve linear equations, quadratic equations. We'll consider more complicated cases in our exam practice 2. Here we have 7 questions. Let's take up the very first one, which is solve the following equation for theta in the interval 0 to 360 degrees. Two questions are given to you. Sine theta equals to minus square root 3 over 2. And the other one is cos theta equals to minus sine theta. You can always pause the video, answer the question, and then look into my suggestions. So we'll begin with very basic concepts and end up with solving quadratic type of trigonometric equations. So the first one here is sine theta equals to minus square root 3 over 2. Now, first thing to review is the cast rule. So as you know, all are positive in quadrant 1, but when we say cast rule, we start writing from quadrant 4, C, right? AST. But strictly speaking, remember that the quadrant 1 is right there. This is quadrant 2. This is quadrant 3. And that is quadrant 4 actually. So all are positive in quadrant 1, sine in 2, tan in 3, and cosine in 4. When we say that sine theta is negative, it really means that the acute angle could be in quadrant 3 or in quadrant 4. So we're looking for two possible solutions in the given domain of 0 to 360 degrees, right? That's the basic concept. So what we are going to do is just to find the related acute angle. So we'll find what this angle is. So the related acute angle is always found in quadrant 1, and we look into a positive value. If you see square root 3 over 2 types, then you know it is also a special triangle. Many times in test papers, the calculator is not allowed. So these numbers, they give you an idea. So here we have our right triangle, whose sides should be 1, 2, square root 3. Sine theta of square root 3 over 2 means we're talking about 60 degrees. So the acute angle here is 60 degrees. The two answers should be given as principal angle. The principal angles which we are looking for should be what? Well, they should be measured from the positive x-axis. One of them is this, which is 180 plus 60. So we can get theta equals to 180 plus 60 degrees. And the other one as theta equals to 360 degrees minus 60 degrees, correct? Which is this particular angle. So these are the two solutions for the given equation. So we get our two equations. So you could actually do like this, that theta equals to sine inverse of square root of 3 over 2. But theta will give you only one angle. So it is always a great idea to always look for the reference angle. So key to learn here is find reference angle. Let's say alpha, and then apply the cast rule, and then report principal angle. Correct? So that is going to be the strategy. And the principal angle is 180 plus 60 is 240 degrees, and here we have 300 degrees. So that is our answer. Is that clear to you? Perfect. So that is how we are going to answer this question. The next question here is cos theta is equal to minus sine theta. Now cos and sine, we could divide both sides by cos, and it can say 1 equals to minus sine theta over cos theta, or you can say minus of tan theta equals to 1, or directly also you could have written tan theta equals to minus 1. Again, let's apply the same cast rule and see what could be the solution. We are looking for negative value of tan theta. That means it should be in quadrant 2 and 4. The acute angle will be found by looking into quadrant 1. For 1, the acute angle is 45 degrees, correct? So we say alpha equals to 45 degrees. So theta could be equal to, that is one angle, 180 degrees minus 45 degrees. The other one is 360 degrees minus 45 degrees. So that is how you are going to get your answer. So when you take away, you got 135 degrees as the first answer. And when you take away from 365, you get 315 degrees as the other answer. So those are the two solutions. Perfect. Let's move on and take up the next question. This is similar to previous question. Solve the following equation for theta in the interval 0 to 360 degree, right? So one full circle. The two questions here are tan theta is equal to tan of 25 degrees. You need to find the solution. The second one is cosecant theta equals to 2. So what is the answer? Well, the very first one, tan theta is positive since 25 degrees is in quadrant 1. The other angle will be in quadrant 3. So this angle is given to us. We're looking for the other angle. One should also remember that the period for tan is 180 degrees, right? The period for sine and cosine is 360 degrees, but for tan it is 180 degrees. So the other answer is theta should be equal to 25 plus 180 degrees. That's our answer, right? So 5205 degrees becomes the answer for this particular question. Correct? The next question is cosecant theta equals to 2. So whenever you get reciprocal identity, it's good to write in sine and cosine. So cosecant theta is 2. That means sine theta will be 1 over cosecant theta, which will be 1 over 2. 1 over 2 reminds us of 30, 60, 90 triangle. So in 30, 60, 90 triangle, the sides are 1, 2 and square root 3. The angle of half for sine means opposite over hypotenuse. We are looking at 30 degrees. So we know that the acute angle is 30 degrees. But there are two answers in the given domain. Again, apply the cast rule. Sine is positive in quadrant 1 and 2. So we are looking for two answers. One of them is already there before us, which is 30 degrees. The other one is 180 minus 30 degrees, which is 150 degrees. So we have our answer here, which is 30 degrees and 150 degrees. So to get started, these are good examples. We have understood how to use special triangles and the cast rules. So we know how to use special triangles and the cast rule. Now let's move forward and do a different kind of question. Question number 3 here is, find the number of solutions for the following in the interval 0 to 360. We don't want the solution, but we want the number of solutions. That is kind of important to understand. The first one for us is sine theta equals to 0, and the second one is cos theta equals to minus 1. So for zeros and minus 1, what I feel is it is better to see the graph itself. So let me just sketch the graph of sine function, which is kind of like this. That is one period. And definitely from here we have the answer. These are the zeros, correct? And the answer is 0, 180 degrees and 360 degrees. And we have three solutions. Correct? So we want the number of solutions. So the answer is 3 solutions. Perfect. Similarly, for the cosine graph, let me just sketch a cosine graph quickly, which is kind of like this. It is minus 1 only at one point. And so we have only one solution. So that is how we should be answering these questions. Many times, these are multiple choice questions, and a simple sketch will help you answer these questions within few seconds. Next question here is, solve the following equations for theta in the interval 0 to 360 degrees. And we have two equations here. The first one is 2 sine theta minus 3 cos theta equals to 0. The second one is cos theta sine theta minus sine squared theta equals to 0. So in the very first one, what could you do? Well, whenever you have sine theta, cos theta together, we could divide by sine or cos and convert to tan. Perfect. So that is the strategy. So we'll follow a few extra steps here. Extra steps help us to understand better actually. So let me rewrite this as 2 sine theta equals to 3 cosine theta. Then we divide, which is sine theta over cos theta is equal to 3 over 2. Or tan theta is equal to 3 over 2. Within the given domain, 360 degrees, we know cos is positive in two quadrants, first and the second. So we have to find the related acute angle alpha, and the other will be 180 minus alpha. So let's find what is alpha equals to. So alpha will be equals to tan inverse of 3 by 2. So let's use calculator this time to find the answer. So we have shift tan inverse 3 divided by 2 equals to 56.3. So we get alpha equals to 56.3. So this time we are rounding it to three significant figures. Let me write down three significant figures here. In many test papers, that is what is the requirement. Sometimes they will also mention to a 10th place. So you have to write answers accurate to ask for. So that is one of the answers. So you can write theta is 56.3 degrees, and also theta is equals to 180 degrees plus 56.3. So let's add 180 degrees to this. And we get this as equal to 236.3 degrees. Correct? So that is to 10th place. Perfect. Anyway, so we have written our answers to 10th place. And our answers in this particular case are 56.3 degrees and 236.3 degrees. Perfect. Now let's take the next example, which is cos theta sine theta minus sine square theta equals to 0. Now this is another category of questions where we need to factor and then solve. As you can see, sine theta is common. So taking sine theta common, we get cos theta minus sine theta equals to 0. So now we could equate sine theta equals to 0, and we could also equate cos theta equals to sine theta. Correct? Even then it will be 0. Right? So sine theta equals to 0, we just found that theta will be equal to 0 degrees, 180 degrees, and 360 degrees. Correct? And for cos theta equals to minus sine theta, what should you do? You should divide by cos so that you get tan. So you get here that tan theta is equal to 1, which is 45 degrees. Correct? We're looking for positive answers, so there are two of them. So theta equals to 45 degrees, and theta also is equal to 180 plus 45, which is 225 degrees. How did we get that? Well, clearly, on this coordinate plane, those were the angles, correct? For tan theta. Is that correct? So we have our answers. So this time we get multiple answers, 180 degrees, 0 degrees, 360 degrees. And here we have 45 degrees and 225 degrees. Perfect. So that is how we are going to solve it. Let's see the next question here, which is slightly different. So we have taken a variation of questions so that you get good review for examination. Question number 5 here is, The equation tan kx is equal to square root 3. The equation tan kx equals to square root 3 has a solution. We are given a solution, x equals to 80 is solution. And we need to find the value of k. A possible value of k clearly indicates that there could be many values of k which can satisfy this particular condition. Well, when tan theta is square root 3, we can always sketch our 30, 60, 90 triangle once again and quickly get to the solution. Tan is opposite side over adjacent, so the angle is here, which is 60 degrees angle. So we know this is 60 degrees. That is one solution. The other thing which we also understand, which we have seen so many times, is that tan has a period of 180 degrees. So there you go. You have the solution which is 60 degrees, and the other one is 180 plus 60 or 240 degrees. That means I could write kx as equal to 60 degrees. I could also write kx as equal to 240 degrees. Since I know that x is 80, I could write this as k times 80 equals to 60 degrees, which I could say here also as 240 degrees. So the value of k is 240 by 80, which is 3. That is one answer. The other I could write as 60 over 80, maybe a fraction, right? So maybe a fraction, 3 by 4. But those could be two answers when we are considering a domain of 360. But remember, this is open question, right? So this is like open interval. You could write many other values of k. So we got two values here. One is 3, one is 3 by 4, and so on. We could actually write more values. Perfect. Anyway, so those two are good enough for us. And if it is not specified, the term here is the equation kx equals to square root 3 has a solution of this. Find possible value. Since they are not even adding s to it, so we can actually just restrict our answer to k equals to 3. Perfect. Makes sense, right? So let's move on and take the next question. Question number 6. Solve the equation 4 cos square theta minus 3 sin square theta equals to 1 for theta, where theta is between 0 to 360 degree. Write answer to one decimal place if required. So here we have a quadratic type of equation, which is 4 cos square theta minus 3 sin square theta. Now earlier we had equations concerning cos theta and sin theta. There we divided by cosine to get tan theta. In this particular case, what should we do? Now here we should remember that cos square theta plus sin square theta is 1. So we could actually rearrange and write sin square theta as 1 minus cos square theta. So if I make this substitution, then we actually get an equation in one trigonometric ratio. And then we can apply the learnings of quadratic equation to solve. So let's do this. So we get this as 4 cos square theta minus, we'll write this as 3 times 1 minus cos square theta. Well, that is equal to 1, correct? So what we get here is 4 cos square theta minus 3, and minus becomes plus 3 cos square theta equals to 1. So that is 7 cos square theta equals to 1 plus 3, which is 4. And from here we can say cos square theta is 4 over 7, or cos theta is equal to plus minus square root of 4 over 7. So that is what we get. So that means all the four quadrants, right? Plus and minus. So let's find the acute angle now. So we can say cos alpha, let's write like this. Okay, so we have cos of alpha, the acute angle we'll try to figure out, should be positive square root of 4 over 7. Let's use calculator to find the value of alpha, which is cos inverse square root of 4 over 7. So we go shift cos inverse square root 4 divided by 7 is equal to 40.89. So let me write this as 40.1. So that is the acute angle which we have got. And as we understand, there are 4 solutions to this. Where the acute angle is 40.1. So the angle theta is equal to 40.1 degrees. That is the 10th place, right? And the other one is 180 plus 40.1, right? That's the other angle, which is 220.1 degrees, right? So I missed one here, which is 180 minus 40.1, which is 139.9. And then we have 360 minus 40.1. So we also have 360 minus 40.1 degrees, correct? So taking 40 will give 320, but this is 0.9, correct? So we get all these answers. So we get 4 answers here as expected. So our answers here are, let me use the space as such. We have answers as 40.1 degrees, 139.9 degrees, 220.1 degree, and 319.9 degrees. Correct? So that is how we find the solutions of such equations. Now, here is the last question for us, which is solve the equation tan theta minus 3 cotangent theta equals to 2 for theta between minus 360 to 360. So see, the domain has been changed a bit. So we get more number of solutions. The question is tan theta minus 3 cot theta equals to 2. How do we solve it? Well, let's write them in one trigonometric ratio. Tan theta is better, right? So we get 3 over tan theta equals to 2. Multiply by tan theta, we get tan square theta minus 3 equals to 2 tan theta. Rearrange, we get tan square theta minus 2 tan theta minus 3 equals to 0. Now we could factor. We need a product of minus 3, sum of minus 2. So we could write this as tan theta minus 3 times tan theta plus 1. So we get a factored form of the quadratic equation, and from here we can get our solution. So we are working on 2 sets. One of them is tan theta minus 3 equals to 0. That means tan theta equals to 3. So we can find the acute angle. The other one is tan theta plus 1 equals to 0, or tan theta equals to minus 1. Right? So that gives you these 2 solutions. Minus means tan is in these quadrants, and the acute angle, as you know, is 45 degrees. So that is 135 degrees, and this is 45 less than 360. Right? So let me write on this side 313 degrees, 315 degrees, right? So which is because this angle is 45 degrees. So acute angle is 45, so get these 2 solutions. And here, let's find the angle theta as tan inverse of 3. Use calculator once again. So it is shift tan inverse of 3 is equal to 71.56, 71.6 degrees. So that is what we get. Now in this particular case, the angles will be in quadrant 1 and 3. Correct? So we have these 2 solutions, which are these. So the other angle will be 180 plus 71.6. Correct. So it becomes 0.6, 115 to 51.6 degrees. So in this case, the answer will be, so we get two angles here, which is 71.6 degrees, 251.6 degrees. Then we have 135 degrees and 315 degree. Correct. So that is how we are going to solve it. The critical step, of course, is this, which converts to a trigonometric equation in quadratic form that could be factored and solved. So in this particular exercise, the main objective here was to understand how to solve trigonometric equations. So we started with very simple one, where direct application of formula, or you can say inverse ratio, could find the answer. And then we figured out how to solve a linear trigonometric equation and then a quadratic trigonometric equation. The last example seemed to be linear, but actually landed as a quadratic trigonometric equation. So that could also be the case. So I hope the whole concept is clear. Kind of it is important to understand that we were required to do it domain in this region, which is minus 362 plus 360. What did we do? We actually wrote the domain only in 0 to 360 degree. So still a part of it is missing. Correct? So what I would like you to do here is, so we wrote the answers in the domain which is from 0 to 360 degrees. Correct? We have still to write the answer in this particular domain. So as an exercise for students, you need to write other solutions. Correct? So from these solutions, you have to see that the solutions will also be these. Correct? Do you get the idea? So that is also a solution. Minus 45 is also a solution. And that is also a solution. So look into these four additional solutions. So we need plus 4 solutions. Then the answer is correct. You get the idea. So when you solve such questions, it is kind of important to understand that full solution should be provided. So I'm leaving this as an exercise to the students. So you need to write additional 4, which will now complete the solution set. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.